Hello, everyone, and welcome back. I'm really thrilled to have you here for today's explainer because we are taking a massive deep dive into the absolute core of application security. We're looking closely at Chapter 2 of our source material today, which is all about the two overarching standards for implementing authentication. If you're building software today, you're essentially building a digital building, and every single building needs a bulletproof way to control exactly who gets in and who doesn't. When you look at the latest security research on these modern standards, there's this brilliant metaphor that just perfectly captures the landscape. I want you to think of authentication as your application's club bouncer. You certainly wouldn't want a bouncer letting everyone in without checking IDs, right? By deeply understanding this landscape, you're going to learn how to be a bouncer who knows exactly who belongs, who doesn't, and precisely what to do with anyone trying to slip by with a fake ID. Mastering these authentication standards isn't just a nice-to-have architectural choice anymore. It's absolutely essential for survival. If you don't know how to authenticate users and services properly, you're effectively leaving the front door completely wide open. So let's level up and make sure your app is vastly smarter than the average bouncer.
Here is our agenda for today. We'll be covering the authentication bouncer, externalizing with SSO, tailoring the user experience, beating phishing with WebAuthn, the developer authentication toolkit, and securing application credentials.
Section 1. The authentication bouncer. Protecting the front door.
So, our journey today is split into two distinct halves. Later on, we're going to head to the back office to secure machine-to-machine communications, but right now, we are entirely focused on the front door, how we actually log human users in securely. Every single application, whether we're talking about a massive monolithic behemoth or a tiny little microservice, has to solve this problem. And the very first step to protecting that front door is recognizing the massive flaws in how we used to do it. So let me ask you this crucial question right up front. Why are passwords terrible for both security and the user experience? Think of passwords as the legacy, broken, fake ID of the digital world. Humans are just terrible at remembering complex strings, so we inevitably reuse the same weak passwords across multiple services. Expecting a user to remember 15 different, completely randomized, highly complex passwords is kind of like expecting a toddler to do your corporate taxes. It's just going to end in tears and a massive, expensive mess. If one random forum gets breached, all of your users' enterprise accounts are instantly at risk. Plus, for you as a developer, securely storing passwords is a costly, risky, and highly complex endeavor. It's not just about hiding a string in a database. You've got to implement proper cryptographic salting to defend against rainbow tables. You have to utilize computationally expensive hashing algorithms, like bcrypt or Argon2, to defend against brute force attacks. And even if you do all of that perfectly, you are still voluntarily holding on to highly toxic data. A database full of hashed passwords is a giant target on your application's back. It's a complete lose-lose situation.
Because of these glaring architectural and security flaws, we absolutely need a complete mindset shift in how we build software. You have to stop trying to build custom login screens. We need to immediately move away from monolithic applications handling their own local authentication. Think about it. Building your own auth from scratch is basically like asking a random employee, say a junior accountant, to suddenly stand by the front door of a nightclub and rigorously check complex, forged IDs. They aren't trained for it, they're going to make mistakes, and eventually the wrong people are getting inside. Instead, you need to upgrade to foolproof, modern frameworks and leverage established industry standards. You must take the massive liability of identity verification completely out of your core application logic. Section 2. Externalizing with SSO. Hiring a professional security team. That crucial mindset shift brings us directly to our first major standard. Applications should no longer be burdened with handling their own user authentication. It is time to hire a highly trained professional security team for the front door. And that professional team is called Single Sign-On, or SSO. SSO is an externalized service that entirely centralizes user account creation and authentication. Let's actually talk about the mechanics of how this works under the hood. When a user tries to access your app, they don't type a username and password into a form you built. Instead, your application halts the request and redirects the user's browser completely away from your site over to the SSO provider's highly secure login page. The SSO provider handles all the messy work for you, checking the password, enforcing multi-factor authentication, maybe even doing some behavioral risk analysis. Once the SSO provider is satisfied that the user is exactly who they say they are, it redirects the user back to your application, bringing along a highly secure cryptographic token. Your app validates the digital signature on that token, and boom, the user is logged in. By moving authentication completely out of your application boundaries, you drastically improve security, heavily reduce your development effort, and provide a massively better user experience. Why? Because users can authenticate once with the SSO provider and seamlessly access dozens of different applications without having to log in again.
Okay, so how do you actually acquire and integrate an SSO service? Security research breaks down 3 specific deployment models an organization can implement, and you choose based entirely on your operational needs. First up, you can use a fully managed software as a service or SaaS provider. Companies like Okta, Google, Amazon, Microsoft, and VMware lead this space. You choose a SaaS model because it's lightning fast to implement, it handles all the infrastructure scaling and removes the maintenance burden, though you do typically pay per user. Second, if you have incredibly strict data sovereignty requirements, or you're working in a highly regulated industry where user data absolutely can't leave your physical servers, you can use on-premise open source solutions like Keycloak. This gives you total control, but keep in mind, you take on the heavy burden of patching, updating, and scaling those authentication servers yourself. And third, you can use a built-in cloud provider service like AWS Cognito or Azure Active Directory. This is really the sweet spot if your entire application architecture is already deeply natively integrated into a specific cloud ecosystem, allowing for incredibly tight, specialized access controls.
Section 3. VIP access, tailoring auth by user type.
Now, our professional bouncer can't just treat everyone exactly the same, right? An enterprise application interacts with radically different types of users: customers, internal employees, and external partners. And each of those requires a totally different VIP access strategy. We can break this down into 3 distinct strategies. Let's start with customers. For the general public, convenience and low friction are absolutely paramount. If it's hard to log in, they're going to abandon their cart or leave your service. You want to offer biometric login with WebAuthn or social login through Google or Apple, keeping standard password-based multi-factor authentication as a fallback. But employees? They have a totally different threat model. You want them using their corporate Active Directory. This centralizes IT control, allowing employees to seamlessly access internal tools, HR systems, and external SaaS services using one tightly monitored corporate credential. If an employee leaves, IT disables one Active Directory account, and their access to hundreds of systems is instantly revoked. And then we have partners. This is where it gets really technical with delegated SSO. If another business needs access to your platform, you definitely do not want to manage their accounts, handle their password resets, or worry about their employee turnover. Instead, you establish a federated trust relationship. You configure your application to delegate authentication directly to the partner's own SSO service. When their employee tries to log in, they authenticate against their company's server. Their server generates a signed cryptographic token and passes it to your app. Your app validates the signature, trusts the partner's assertion of identity, and grants access. It's completely seamless business-to-business collaboration, totally free of the user management headache. Section 4. Beating phishing with WebAuthn, the ultimate defense. So we need to protect our most vulnerable users from the absolute most common and devastating attack on the internet: phishing. Phishing is when an attacker tricks a user into entering their credentials on a fake look-alike website. Look, no matter how much security awareness training you do, humans will eventually fall for a perfectly designed fake login page. We need a technological way to completely defeat this. Enter WebAuthn. WebAuthn is a modern web authentication protocol that enables completely passwordless login. Users can authenticate using the biometric scanners already built right into their phones or laptops, like Apple's Face ID or Windows Hello fingerprint scanners. But here is the crucial developer aha moment regarding how this actually works under the hood. WebAuthn completely eliminates phishing by utilizing public key cryptography that is permanently tied to secure hardware. When a user registers, their device generates a cryptographic key pair inside a secure enclave, or trusted platform module. The public key is sent to your server, but the private key never leaves the physical hardware of the device. When the user tries to log in later, your server sends a cryptographic challenge. Now here is the magic part. The device will only sign that challenge with the private key if the website URL in the browser exactly cryptographically matches the origin URL it originally registered with. Because the protocol strictly validates the domain before authentication even occurs, traditional phishing becomes mathematically impossible. If a user is tricked into visiting a fake lookalike site, the device simply refuses to hand over the credentials. No way around it.
And hey, if device biometrics aren't quite enough for your threat model, we look to dedicated hardware. For the absolute highest tier of security, think system administrators, database engineers, or high-value financial accounts, physical hardware keys, such as a YubiKey, utilizing the exact same WebAuthn protocol, are the ultimate upgrade for your front door. It requires the actual physical presence and touch of the key to complete the cryptographic signature, completely neutralizing any remote attacker. In fact, to put this into perspective, when Google mandated physical web auth and security keys for all of its tens of thousands of employees, they successfully reduced successful account takeovers via phishing to zero, literally zero. That is the incredible power of this standard. Section 5. The Developer Authentication Toolkit, standardizing the front door. Okay, we've spent a lot of time talking about what the bouncer does and the protocols they enforce. But what is your direct responsibility as the developer when you're integrating these systems? You need to know exactly which tools to pull from your toolkit to make these integrations happen seamlessly. As a developer, the absolute most important protocol you must master today is OpenID Connect, or OIDC. OIDC is an industry-standard protocol widely used by modern SSO services. Actually, it sits directly on top of another famous protocol you've probably heard of, OAuth 2.0. While OAuth 2.0 is designed for authorization, meaning granting access to resources, OIDC adds the critical identity layer right on top of it. OIDC provides a universal API for interacting with identity providers. When you use OIDC to redirect a user to an SSO service and they successfully log in, the SSO service redirects back to your application with a very specific payload called an ID token. This ID token is formatted as a JSON Web Token, or JWT. Inside this JWT are what we call claims, cryptographically signed pieces of information about the user, like their unique ID, their email address, and when they authenticated. Because the JWT is digitally signed by the SSO provider, you, the developer, can easily verify the signature locally in your own code, trusting the claims without needing to make a heavy, slow database call. Whether your application is talking to Okta, Google, or Keycloak, OIDC is the beautiful, universal language it uses to do so. There's a golden rule in modern security architecture that perfectly defines the boundary of your daily job. Information security engineers choose and configure SSO services. Developers implement OIDC in WebAuthn integration and applications. Your job as an application developer isn't necessarily to spin up, configure, and secure the backend of an enterprise Okta server or an on-premise Keycloak cluster. No, your job is to deeply, fundamentally understand how OIDC redirects work, how to securely parse and validate JSON Web Tokens, and how to implement WebAuthn APIs in the browser. By mastering these specific developer-focused standards, you can seamlessly and securely connect your application to whatever overarching SSO infrastructure the security team ultimately chooses. Section 6. Securing Application Credentials, the Back Office Vault. All right, now we're pivoting. We are leaving the front door of human users behind and heading deep into the back office. Because modern software isn't just about logging humans in. Monolithic applications and microservices constantly need to talk to database servers, event streaming platforms, message brokers, and third-party APIs. This means your machines need their own credentials to communicate securely. Look at these stark contrasts between how we used to handle machine secrets versus how we absolutely must do it today. The old way, the highly dangerous legacy method, was storing API keys, digital certificates, and database passwords right in plain text within application configuration files or environment variables. This is a massive vulnerability. If an attacker breaches your code repository, or, if an employee accidentally makes a GitHub repository public, they instantly get the keys to the entire kingdom. The modern best practice is storing those highly sensitive credentials in centralized credential services, like HashiCorp Vault. You externalize the machine secrets entirely, completely separating the code from the credentials. Why is externalizing machine secrets into a specialized vault so critical to modern architecture? Well, let's weave these immense benefits together. First, a vault acts as a single source of truth for all your secrets across hundreds of microservices. When a database password needs to change, you update it in one single place, instantly providing easy updates without having to dig through massive code bases just to redeploy code. This leads directly to simplified credential rotation. Imagine a Friday night where you suspect a database password was compromised. In the old days, that meant an emergency, all-hands-on-deck code deployment that takes your applications offline. With a modern vault, the vault can be configured to generate dynamic, short-lived database credentials on the fly. When your application requests access, the vault creates a temporary password that automatically expires in 15 minutes. Even if it's intercepted, it's useless almost immediately. Furthermore, every single time a machine requests a secret, it generates comprehensive audit logs. You know exactly which specific microservice accessed which payment API key at what exact millisecond. And finally, for the highest level of assurance, enterprise vaults run on hardware security modules, or HSMs. An HSM is a physical computing device designed specifically to safeguard digital keys. If an attacker physically tries to tamper with the server rack, the HSM automatically zeroes out and destroys the keys. Losing application credentials can lead to catastrophic, company-ending security failures, and a centralized hardware-backed vault is exactly how you prevent that. So the crucial point here is a bit of a warning, and honestly, it's a real pain point for developers. Unlike user authentication at the front door, where we have the beautiful, highly standardized universal language of OpenID Connect to seamlessly talk to any SSO provider, securing machine credentials in the back office is a much more fragmented landscape. Unfortunately, no industry standard API currently exists that universally works across all credential products. This means that as a developer, you have to learn the broad, generic architectural patterns for securely requesting and caching application credentials in memory, but you also have to do the hard work of learning the specific proprietary APIs of your chosen vault provider. Whether your infrastructure team dictates HashiCorp Vault, AWS Secrets Manager, Azure Key Vault, or CyberArk, you have to learn the specific dialect of that exact tool. You just don't get the luxury of a universal standard here, which means your code needs to be cleanly abstracted so you aren't tightly coupling your business logic to a specific vendor's SDK. As we wrap up this deep dive, I really want you to slow down and reflect on the architecture you're building right now in your day-to-day work. Is your application genuinely acting like a smart bouncer, outsourcing human logins to a highly professional SSO security team using OIDC, and making phishing mathematically impossible with WebAuthn? And do you have a truly secure, dynamic back-office vault guarding your sensitive machine credentials? Or are you relying on legacy practices? Are you leaving the front door broken, forcing users to juggle weak passwords and custom login forms? And is the back office completely unlocked, with your production API keys sitting in plain text right there in your source code? It is time to step up. Implement these powerful modern standards and definitively lock down your digital building. Thank you so much for joining me as we unpacked these crucial authentication mechanisms. Catch you in the next explainer.